It starts with the question, and we see what's true. A hunch or an idea, what happens if we do? We try it out live, the results never set. Sometimes it's a breakthrough, sometimes a regret. Then come the voices to carry it through. Alan and Andres with experiments for you. From agents to APIs and all in between. Some turn into magic, some break the machine. When the answer is fuzzy or clear as day, we'll learn it together along the way. So pull up a chair, what should we expect? We're laughing and learning, it's no check. Yeah, that's no check.
Good
Hello.
afternoon. I love that. I love that intro. That's so much fun. So much fun. My daughter, she'll randomly say, "Hey, can I watch the Alan Helton video?" She loves it when I walk in and the animals surround me and then I look at the camera. She thinks, even at her age, at 7 years old, she thinks it's cringe. So it's super funny for me.
Works out. It works out.
It does. Yes, it does. Well, hello, everybody, and good afternoon for some, good morning for others, good evening for our European audience, and welcome. If you are new here, my name is Alan Helton. I'm an ecosystem engineer at Momento. And who's this handsome guy in the orange hat?
This is Andres Moreno, principal architect at Calent. Nice. And my coworker here, Brian Tarbox. Hey, how you doing, Brian? Thanks for joining us.
That's right. And fellow AWS hero as well.
You see, we're collecting the 6 degrees of separation is just 1 degree for you and me.
Yes. Yes. And it looks like we stream through an app called StreamYard, and it looks like they've changed the layout of our comments section. So it's going to bleed over onto my camera for as long as I could tolerate it. And then I'll probably turn it off because I don't like it. Yes.
We'll have to fix the layout for the next stream.
Yes, we will. But we're not here to talk about layouts and all that. We are here to talk about building enterprise-grade AI agents. Now, Andres, you and I have been on a series, a whole kick on design principles for AI agents. It's a lot more than just going to chatgpt.com and asking a question. As you know, that's what my parents think an agent is. Anyway. So if you guys haven't caught it, we are on episode 4 or part 4 of our Enterprise AI Agent series. And we've been going through a bunch of basically just design principles. We're not looking at code. We're not looking at actual inputs and outputs. Really, we're talking about concepts. And then we are using our test harness called Promptatron to
3,000.
show you guys that we're not just, full of hot air. Super, super fun. Today is actually going to be a little bit of a departure, though, because our topic today is on validation. Our design principle is, let me read it. I'm going to bring it up off screen. I'm going to read it out loud. And it's going to sound super polished. Design principle number 4, validate and revise outputs. Run generated content through policy, regulatory, and business rule checks. Regen if it fails. Now, actually, Andres, you and I came up with these together. And this one, I think, needs to be updated because it's really all about outputs. And one of the things that you and I learned when we were preparing for today is really this one is a lot about inputs, not so much output.
Yeah, so definitely we need to validate and revise our output for this principle. So as we dug deep into the preparation for this, right, we'll go into the details. There's a lot of input validation as well that you can do and should do, and we'll go over why in a bit.
Yeah. We don't even have to keep them hanging. We can just dive straight into it if you'd like.
Yeah, let's go for it.
I love it. Last time we talked too much. We had too much banter at the beginning, and I feel like we didn't get enough content out the door. So today, I think we should go, because there's a lot here. There's a lot of cool things. Now, as a reminder, all of these design principles that we're talking about, they apply to autonomous AI agents, which are the ones that are responding to events inside of your system. That could be an API call, it could be a database write, it could be a database read. Really, it's events. It's not us sitting at our computers and chatting back and forth with a chatbot. We're not talking about that. Those are valid use cases, where there are a lot of agentic use cases when you hook up Claude to MCP servers or even ChatGPT and enable them to go and perform actions on systems. But Andres and I like to focus on builder scenarios, which are implementing AI agents behind the scenes. Really, you would have no idea that there's an agent involved or AI involved at all, except that you get lightning fast turnaround when you put an input into the system.
And it'll make you think you're smart.
Why?
Because it always tells you, like, hey, yeah, good idea, or you're awesome and perfect.
Oh yeah. That's right. That's right. I did send Andres a screenshot from ChatGPT today. They gave me a 100 emoji and said, "You're exactly right again, Alan." It's like, yeah. Glad somebody talks to me like that. Anyway,
probably the only person that does it for you and me, not just.
Yes. Okay. So let's talk about validation. There are two different types when we're working with LLMs. There's input validation and there's output validation. Now, the design principle that we wrote together, validate and revise output, that's really making sure that the LLM, the non-deterministic part of everything, is doing really what it's supposed to do. And even when you follow the other design principles that we've spoken about, which is strong system prompting and providing just the right amount of context into your messages and building tools that are meaningful, it can still go awry, or it can generate something that doesn't adhere to your business policies. So validating on the output side of that with guardrails or business rule policies is actually really important before you return a response to a user or you act on the system. Now, equally as important is the data that goes in, because people are bad. Not everybody's bad, but
I don't know.
Malicious users can and will identify that you have an LLM in your system, and they will try to do things to manipulate it. However that is. A big Andres, if you know this one, a big attack vector for input on LLMs is, love putting you on the spot, prompt injection.
Okay, yeah, it is.
Why don't you explain prompt injection for us?
Yeah, so I mean, I like to pair things up to things we've usually dealt with in the past, right? So think of a prompt injection like a SQL injection, right? Where you're going to provide an input, and in that input, you're going to embed a delete users table, right? So similarly in prompt injection, they'll ask for something. And I know we've manipulated several chats, like, hey, give me, instead of just talking about Amazon products, you just use it like ChatGPT and it's for free, right? So that's not super malicious, but they would inject a prompt that will make it act maliciously in your system, similar to SQL injection.
Yeah. Or even just off topic. You touched on it, but something that I did when Amazon just implemented Rufus, which is their little product AI, which went into the mobile app. And I think it's in the web app now too, but it just said, do you have a question? Just ask. And I was like, well, let's see. Can you write me a JavaScript file that will do whatever? And it did.
Yeah.
Because there weren't any guardrails that kept it on topic. So we'll talk and look at some of the guardrail options that AWS has with Bedrock. They're actually very, very thorough, way easier than I thought too. We'll look at that and have some good times with guardrails.
For sure.
But before we do that, I would like to introduce a fun use case, a real world actual use case. And I'm going to actually start bringing stuff up onto screen now where we have an actual legitimate enterprise use case here. So what we're doing is we are integrating an AI agent, an autonomous agent behind the scenes for a delivery company. This one's called Swift Ship Logistics.
Ooh.
And we have two use cases that we're going to go over today. One is a delivery driver who was not able to deliver the package to the customer. So that's what I have up here on the form. There's an order ID, why, and some notes, some free text notes for this use case. And what's going to happen behind the scenes, or what would happen in a real scenario if you actually coded it out, is we're going to react to those notes. We're going to take all the inputs from this form. We're going to do some lookups, and we're going to see what actions need to happen in response to the notes. This is really where AI is useful, because anything could go in the notes. And we want to be able to make sure that we're hitting our SLAs, that we're saving cost for the company however we can by reacting to valid business scenarios. And then the other scenario that we're going to go over today is on the other side of it. It's the customer side, where they're looking at their shipment online and they say, well, dang it, it didn't make it to me again. And we're going to put in some information in here. We're going to leave some both nasty comments and nice comments, and we're going to show what would happen in a scenario behind the scenes. So this is a real world scenario. This is something where we can use AI to decide what types of actions to take based on the free-form nature of the inputs. Now, this is autonomous, so hands-free. We're not sitting here and going back and forth with a chatbot. We're actually communicating with a system and interacting with the system, and it's intelligently figuring out what needs to happen. So we have these little things. So prepared today. I'm like ultra prepared today, and I love it.
Yeah, it's a web app just
so
to explain.
Yeah. So let's look at a production system real quick before we go in and actually do things, because level setting on this is critical for everything we're about to talk about after it. So I know this is zoomed out, so let me zoom in. In a real world production system where we're integrating an AI agent, we have our inputs. We have our driver portal and our customer portal. We just looked at what those look like visually in our user interface. And those would traditionally hit an API layer. API gateway is going to go and then call a service. And that service is going to then do a handful of things, right? It's going to actually do the business logic. It's going to figure out what the next steps are. And then typically what's going to happen is it's going to enqueue an event. It's going to use to talk to AWS, it could use SQS, it could use EventBridge. Basically, it's going to send stuff off to process async when these things happen in our system. So nobody's waiting on anything. These are things that just happen, if you will.
Magic.
Yes. So we have here our queue. The queue is going to go to an event router. That event router is likely going to have some sort of classifier or more business logic to figure out, do I actually need to do something? Is there something in here? It's your guardian. And then it's going to pass it over to our triage agent which is going to do stuff. It is going to figure out, do I need to take action? And then based on everything that we've already talked about in our other sessions, Andres, with the tools and system prompts and everything, it can go in, execute tools that communicate with the database for both reads and writes and do the actions. It can escalate situations up. Ultimately that's writing to a database, but figure out what to do from there. And this part, this red section, is what we're focusing on today, because if we have the option to not call an LLM, we shouldn't. It's expensive. It adds variability. It will take your deterministic workflow and immediately turn it non-deterministic, and we don't want that. So if we can go through and find a deterministic path to the end, we will take that. That's why guardrails is super important.
Yeah, and
Makes
it
sense,
integrates
right?
it integrates very nicely with the full system. And one important piece, right? And again, pairing it back to traditional ways we've thought, it's as far as the input and not executing is your sanitation step. It's you're validating the body of the request in an API to either return a 400 or process, right? If you're missing the order ID when you're trying to make a claim or something, you can't process it, right? Because I don't know which order it is. So you're not going to send it for processing. So very similar. And again, with the prompt injection, we always sanitize inputs. This is kind of your way of doing sanitation for agents.
Definitely. With guardrails, we have two types of failures. We have our input failure, which I would say is fail fast, where we are doing the validation up front, all the information, all the prompts, all the text that we're passing into the LLM. We can validate that without even talking, without even considering going to the LLM. And that will allow us to fail fast and short circuit our workflow and allow us to get back to a resolution as quickly as possible. And then we have output guardrails, which are the things that are going to evaluate what the LLM says, where we're going to be failing safe. Distinction between fail fast and fail safe, because that's going to look at what was generated and figure out, does that adhere to my business rules? Is that something that I feel comfortable acting on? So that's what we're going to be doing here.
And this is, again, since we're doing this for enterprise systems, right? You usually have regulations or any compliance or the tone things come out of, right? So it just creates that trust and safety for your, I want to say customers, but maybe the consumers of the output of the LLM, right? So this is where you protect that so that it doesn't offend anybody or break any rules from your business.
Yes. Of course, it's not just about offending people or not, right? It's a lot about safety, but that is a big one. That is a really big one. So that's our workflow. That's a production grade actual workflow where traditionally what we've done, what we've built is this. We have our input, our API layer, our service layer, and the service layer communicates back and forth with the database. Now, when building with autonomous agents, this event router is also in traditional architectures as well to carry on with other async workflows. But with autonomous agents, this AI agent runtime block, that's the new piece. That's the piece that you and I focus on all of these. So that's where we live. That's what we're going to be looking at today. Okay, so that's the diagram. Should we look at some code for like the first time ever on this show?
I mean, we love code, so yeah, let's show some.
We do love code. We do love
make
code.
Some people happy.
Okay, so let's look at the driver. So this is, I would consider this to be actual production level code for building an autonomous AI agent that handles the driver input. Now, I did implement in our little website here, Andres, light mode and dark mode, because I can't stand looking at code in light mode. I can't be the only one. I can't be. So I'm going
to have all the important pieces for a web page. So thank you for including that.
Yeah. Okay. So we're going to go into this and we're going to start at the handler So this is going to be a lambda function. We're just going to say that. Where is my handler?
So much code.
It is a lot, but production code is generally a lot.
Guardrail. I don't see.
I think I'm just not scrolling far enough up. Yeah. Okay.
There you go.
This is the lambda function handler. And remember, what we're trying to do here with this code is not call the LLM. This is the agent code, and we don't want to call it for cost, for determinism, for speed. We don't, if we don't have to call it, we won't. And we're going to walk through the different layers of validation that we have to run in order to not call our LLM. Okay, so let's walk through some of this code. First thing is basically input validation. It's the thing that we should always be doing that is not novel in any sense of the word. Yeah. Does the input look like we would expect? And we do this because we have to format, really the output of this code is a prompt. And we want to make sure that the prompt is going to contain the information that it needs to contain in order to act accordingly. So we have to validate that that body comes in with the data that we expect. Easy enough. We're going to validate the input structure. This can vary based on your implementation. I like Zod personally. If you're going to be using TypeScript, it's just a schema validator. Andres, you and I have also used just AJV, just JSON schema validation. Anything that you need, this is obviously JavaScript specific. So Python has their own validators as well. Whatever it is, validate the structure. And then if it doesn't adhere, abort. We're short circuiting from here. This is not a valid situation, and we're gone. Easy enough. We don't have to spend a lot of time on that one.
Yeah, that's pretty traditional validation.
Yes. So the next thing is we're going to build a context. So it's basically your transform, right? In any ETL layer, you're going to enrich, transform, and L. What does L stand for in ETL?
Load. Extract,
load,
transform, and load.
Okay. I mean, I would feel like that's the same as E, as enrich.
No, it's anyway. ETL is it's I guess in a different
is it
context.
Extract?
Extract, transform, and load.
Okay.
Yeah.
Okay. So this is our T in our ETL, where we're taking the input from the raw database structure and we're creating an input that we can use to basically convert it into a prompt and also run a couple more business validations to make sure that we even need to go talk to it. So we got that. We can look at that code if you want, but this is just a transformation. Nah.
Yeah.
Okay. This is the one that we will look at. We are going to go and look at the implementation for apply short circuit rules. I used the term when I was building this short circuit because we're all developers watching this and we know what that means. In probably actual production code, we might call that business rules instead of short circuit rules because that's exactly what it's doing. So let's scroll up and find that. I put too much code in here. It's my own fault.
Yeah.
I just got so excited.
You love code. There it is.
I do. I just love agents so much. Okay. So this is applying our short circuit rules. And up here, I have a comment for what actually it's doing, but we'll look at the code because we're developers and we like looking at code.
Yeah.
So all this is doing is just looking at if statements. All it's doing is building if statements. So we're checking, does it contain hazardous materials? Context dot contains hazmat. That's what hazmat stands for, hazardous material. Then we're going to say, you have to hold that for pickup. Our business rules are, this is how we run our business. If there's something, right? If there's lithium ion batteries in there, you're going to have to come up to the depot and pick this up yourself. We're not going to leave it at your door. So we're just checking that metadata flag on the order. If it does have that, yep, okay, you're gone. We don't need to call an LLM because our rules are you're coming to see us. 2, we will look at, in this specific scenario, what is the type of failure? Like this is where it actually gets into very specific scenarios where, okay, well, the customer wasn't.
Oh. Hold on, Alan. Video's frozen.
Am I back?
There
Am I
you
back
are.
now?
You're back. Yes.
Okay. I don't know how much you heard or didn't hear. I saw your
You
face
just
get sad.
yeah, I missed you. You just started talking about the specific exceptions.
Okay. Yeah. So this is a specific one. This one basically is another very specific business rule where we're saying this is a standard tier customer. They're not paying us extra. They have perishable stuff in their package. They've only tried to deliver it once and the customer wasn't home. So we can deterministically say, all right, well, we're just going to do a retry. We're just going to schedule it for tomorrow on the standard route rules. And then really that's what we're doing for all these other ones, where if we've tried to do it more than 5 times, then we're just going to bring this up to a manager to make a decision on. If there is a heavy package, which again takes special gear, it's a whole thing. OSHA has to get involved when we're dealing with super heavy packages, then it's going to, escalate that into new things. So really, the whole thing here is talking about valid business scenarios that we can deterministically decide based on the metadata, right? It's how we used to build things.
Yeah, it's and
prior
that's
to
what I
this.
want to mention a little bit, right? Just because you can use it and validate it at the LLM level, you don't have to. And we fall in that trap where you just want to do the LLM does everything, right? So you just define all the business rules are now going to the LLM instead of you just coding it like you used to, because you don't need to take in the cost of an LLM when it's this type of if-else situation, right? You don't need it. And I always relate it to when you're doing like a math problem or a physics problem, you're just going and nailing down on the calculator and somehow you end up doing a 1 + 1. It's like, was that necessary? No, but you're just so in the flow of things that you just type it in and you're like, why did I do that? I think we're doing that with LLMs and agents, that where we're just having it take all the control and not wanting to code these simple paths and simple rules before we actually call it and save some money.
Exactly right. Yes. And that calculator example, it just hits so close to home because I definitely have done like 5 + 6 multiple times. It's like, I know what that answer is, but I'm still going to do it anyway because I'm already in calculator mode.
Yep.
So totally agree with what you're saying. And in a traditional programming, if we didn't have an LLM in the loop here, if we weren't building an AI agent, we run through our business rules, our basically if then else. Our else is down here at the bottom. No short circuit. So we're going to do X. Traditionally, probably escalate to a manager, right? Yeah. So your manager is going to get overwhelmed and there's a whole infrastructure on making sure that the managers respond quickly. Now we can offload that over to LLMs. So that's what this says. This is a complex scenario. Let's let an agent do something. Okay. Lovely. So that's 2. That's validation number 2. There are 3.
Mm-hmm.
Validation 1, does the input look right? 2, can we evaluate with deterministic business rules? 3,
where is it?
There we
there
go.
You go.
Yes. There's so much code. 3, let's apply the guardrails right now without talking to the LLM. This is one of the things I actually really like about Bedrock is you can do the apply guardrails API call with your configured guardrails. And we're actually going to look at those in a minute.
Yep.
And evaluate the input. It's doing the input guardrail validation, which we'll see in a minute, has a lot of config, a lot of different things that you can use, and you should tune based on your situations. So thinking about this scenario that we have right now, this is a driver that works for our company. He could be malicious if he gets super disgruntled, but probably not. So our input guardrails can be a little bit looser, or we can just say, don't block everything, just warn. And maybe we'll have this guy's manager talk to him in the future to say, hey, you got to stop or you're out.
Yep.
So this is just calling the Bedrock guardrails, and all it's doing is passing in the input. And then based on the result, if the guardrails intervened, that's the technical term here. Did they intervene? Yes, we're out. We're not calling that LLM again. The input is no good for whatever reason. And that would come in here in the violations object. We're not going to talk to the LLM. After 3 rounds of validation, now we can talk to the LLM. Now we can generate that prompt with the input that we know is right. We can create that and then send that over. We use the Converse API. We like that one. But we can send it over to our agent framework to actually go and run.
Yep.
What a setup. What a setup.
Yeah.
There we go. That's everything. That's everything. That is the production level code. That's the workflow that we'd run through. Now let's see it work. Let's actually see guardrails work. So what's going to happen here is we made some enhancements to Promptatron this past couple of weeks, which is our test harness for agent building. Free, open source, everything runs in your AWS account from local disk. So it uses the CLI to log in and whatnot.
Yeah,
it doesn't actually
has
deploy
scripts.
anything.
It has scripts and everything to log you in and pull. If you're using SSO, it'll pull out the access keys and kind of provide them for the web app to do the API calls with AWS with those keys. And the most importantly, I mean, the best feature added from last stream is Chad can now move around on the screen. So if he gets in the way, you can
which he did last time.
Yeah.
I think this was our highest priority story on our Jira board for this thing definitely. Was to get Chad out of the way. Anyway, so what we're going to be running is a 2-part thing. We're going to look at input validation and we're going to look at output validation using Bedrock guardrails. We're going to use the Converse API and we're going to use Bedrock guardrails to do that. And I don't have a apply guardrails path, which is what you would do in a production scenario. We're just going to kind of apply that as we talk to the LLM. Cool. So do as I say, not as I do, really, in this situation. Didn't have time to build the apply guardrails. But we're going to run through the same thing. This is the same type of scenario that we ran before. It's our shipping logistics scenario. We have our guardrails in here, and we can take a look at this before we actually give it a prompt.
Yeah. So, and this is all the configuration that is accepted in Amazon Bedrock, right? So if you go through the AWS console, this is what you have. So you have these types of, they're not configuration types, I guess, but guardrail configuration types.
Yes.
Which are these top levels. Go ahead.
There are 2 words here for the configuration. There's policies, which are kind of the higher level. There's topic policies, word policies, contextual grounding. We'll talk about all these. Content, sensitive information, automated reasoning. Those are called policies. And you can have multiple configs inside of those different policies. So you can say, I don't want you to talk, or I only want you to talk about shipping logistics and fish. I'm just trying to come up with something. But that's the kind of thing. So a config is like an individual setting inside of a policy.
Okay. Beauty.
And there's a lot.
Like you said, there's a lot of configuration that can go into all of this, right? And it could be fine-tuned for your specific compliance reasons or protections or your own policies, right? So they're very flexible and can be very, very fine-tuned.
And that's what I want to do right now. So I said earlier, we're going to go through 2 scenarios. One with the driver who works for us and we trust him at least a little bit. And we have our untrusted input,
User.
which is the customer who could say anything. So the first one that we're going to work with is the trusted source, so we can tailor our guardrails appropriately. So let's figure out how we would configure these for a trusted input that comes from internal. So this is, I mean, I tried to make this as intuitive and easy as possible for these. There's a lot of interesting and new concepts with guardrails.
We're not user experience people, so we try our best. So it makes sense to us. Maybe it doesn't for everyone else. So let us know. Give us feedback.
Yes. So relevance threshold is basically making sure that you're not doing prompt injection and trying to steer the LLM away from its task. With an internal one, we can probably dial it back a little bit. Let's just say it's 0.2. I don't actually know what confidence threshold is. Grounding confidence threshold determines how certain the AI must be that its response is properly grounded in your source document. So we don't have those. So let's just dial those back. Okay. So what kind of policies do you think we would have for an internal, Andres? Probably not topic. We don't really have to worry about that, because anything could happen.
About Alan asking Rufus for code. Yeah.
Yeah.
Word
policy.
Probably. I would.
Yeah. Definitely want sensitive information. So this is like PII. You don't want somebody, you don't ever really want to trust that personal identifying information going in or out. So we can take a look at that. We haven't implemented automated reasoning yet, but this one, I left this in here because we should talk about it. It is using math to deterministically validate what the LLM output is correct. So there's a whole setup for it, a whole thing. You have to have docs and different scenarios, and then you can use that as follow-on to say yes or no, this is right. So we had a comment in here. It said grounding checks are helpful for RAG and summarization systems. Totally makes sense. Totally makes sense, because that's what they're doing, right? That's what that description said. It's going to validate against your docs. So using RAG, which is using a vector database or some other knowledge base to augment the knowledge of the LLM, we're going to validate against that. Okay, word policy. Andres, this one is, it doesn't like specific words or phrases. Do you think we would configure that one?
Yeah, I mean, yeah.
Okay. So for that one, you can actually set specific words, and then there's a profanity filter down here at the bottom.
Okay, I didn't want to have to type in those 4-letter words.
No, those nasty words.
So, yeah. So thank you for AWS for just providing a profanity. So yeah, I would do it mostly for profanity.
That makes sense. Now here's an interesting concept. We have input and output for word policy. And chances are good a delivery driver, if he's angry, might use profanity in that message. So we can choose to either block it, we're not going to do anything, or nothing, which is basically just going to make a note of it, but continue, which I think is okay.
Yeah, so this could be add a note to then notify the manager, for example, but you can keep moving as long as that profanity doesn't make its way back to the customer.
Yes.
Which we have a separate control for that. So yeah, I think we're good.
Exactly. No back to the customer. So we're going to block on the output, and we're going to pass through and log on the input. Sensitive information on the input. Do you think we need to add anything?
I think PII do we need to,
what would you do? What would you block, or would you just pass through for sensitive information going in?
It really depends on the industry you're in and the type of PII. But I would.
It does.
And your protections around your LLM usage. So at this point, my first thought would be to block PII into going into the LLM until you safeguard your actual LLM to not do anything with that PII in its training.
It's an
or anything.
interesting balance, because PII, if we look here, this is all of the options for PII that AWS provides out of the box. You know, of course, you wouldn't want people passing in like passport numbers and whatnot, but address for our specific use case for a delivery, that's actually totally fine.
Yeah, I think
I think
address, age,
yeah, go ahead.
address, age, and credit card CVV probably are, or any credit card information would be our biggest
Yeah.
PII concerns.
This is an interesting one, because this is talking about delivering to an address. So you have to figure out, you know, what's acceptable and what's not. Because if we block this, the person can't ask questions about it. There's an option for sensitive information to anonymize, but if we anonymize the input, then tool usage is not going to work.
That's
If
true,
it's
because we
gonna,
have like
if
the
it has
expedite shipping and all that. That wouldn't work because you can't.
exactly.
Yeah.
So with this one, I probably just wouldn't, or I would
Well,
add another pattern, or no, probably wouldn't use this.
yeah, no. And it's again,
I
it's
might
protecting at a
anonymize it
different
on.
level, right? The concern there is, for me, it's okay, it goes to an LLM and you don't have the correct policies within that LLM to not train, retrain with your data. That's where I would put that protection, because our business use case here wouldn't work if we block that specific item.
Yep. Let's do this though. For the sake of the demo,
Yes.
let's block address, phone, and name, and anonymize on the way out address, phone, and name.
Perfect.
I don't think this would be a real good one, but it is what it is.
We'll see.
And then contextual grounding in here is what we had already said. We're not using RAG. I could probably get rid of that.
Off.
So we have our profanity filter and we have sensitive information filter. We've lowered our threshold. Let's see what we can do to get this blocked. Okay, so everything's set up. We have our delivery agent system prompt.
Not
where
gonna go through that.
No, we don't need to. We had a whole episode on that.
Yeah.
And what we're going to do is we're going to jump back over to our other little website here. We're going to run through a couple different scenarios that are fun. So let's say B456, I'm the delivery driver right now. This is the persona hat that I'm wearing. And we're going to say, we're going to use this default one here. I don't know, man. Box was making weird noises. It smelled funny. I left it at the depot and the customer wasn't home anyway. So we're going to say that's a damaged or unusual package and we're good. So in our little test harness here, this is generating the user prompt that's coming into Promptatron. So this would have already run all of our code that we went through and said, okay, you're good. Go ahead, talk to the LLM. So copy, come over here, user prompt.
And this is just statically generating this, right? So it's not like going through an agent generating a prompt. This is just going through the information you've provided to build our user prompt how we want it. So
exactly. Yes. So in theory, we don't have anything in here that would activate these guardrails. I don't think. Let's see. What model are we using?
Nova, right? Yeah.
Pro. Okay, good. We'll just do detect. We don't actually need to use our tools. Let's go. Okay, so it does say the guardrails intervened.
What do you do?
Why? So it says the input. So something that we had on the input said no. Thinking about
It's
that
the
agent
address,
code that we
right?
walked through. Is it the address? Let's see.
I think I saw it.
It has a name, so it probably keyed off that name, which is PII. Let's try removing that. So there's no name. It's just Yeah. Okay. Let's try that. Okay.
Yep, that
So
worked.
that was it. Now it actually did something. Something. I don't know what, but it did not respond back, or it did not trigger the guardrail. So that name that we had in there initially
Was
was
blocking it.
triggering for it. Yep. Let's try another one. Let's try another use case. These are fun. I have
Yeah,
some.
it's fun
I have
actually
some.
seeing it work.
Yeah, right. Okay, here is a standard one that is probably 9 out of 10 of failed delivery comments. Customer not home, left at the door, we'll try again tomorrow. And so what that looks like is here, it's basically the same. Going over to Promptatron.
Has the name as well, so it's probably going to block it. But maybe let's have some fun and let's disable the name from the PII block.
Sure, let's see it fail. And then it says
It is.
input. And then
And as you can see,
disable.
at this point, we talk a lot about determinism, right? So this is giving you a deterministic path with these validations, right? So not waiting for the LLM, which can do whatever it wants with the information. So I still see the
It still blocked it, which is weird because it shouldn't, because we took off name for PII. It worked that time. Don't know why. Also don't know why our tools aren't showing up. I probably broke something building this, but yeah, it is what it is. The good thing is that we can see that the guardrails intervene or
part.
they don't. Yes. Okay, let's do an interesting one. This one that I have conveniently off screen. Box is leaking unknown liquid. Label reads UN3481 lithium batteries, manifest ID, blah. And that is this one.
Unusual, yeah.
So for this, I made this one because I was thinking it was PII by having the manifest ID. I was thinking this might be a bad thing, but this is a weird scenario because maybe we want that information, or maybe that's something that we really do want humans to intervene on.
Mm-hmm.
See what it does. Oh, well, it immediately responded with something. And it did not trigger. Don't you just love it when the LLMs just don't do what they're supposed to? Okay. It's a little frustrating for me, but it is what it is. Let's go through the other workflow.
Yep.
Now that we see that that's not behaving the way I want it to behave. Let's look at customer. So this customer is angry because the delivery was out for delivery. She was excited, and then she gets an update that says the delivery failed. She's a VIP platinum highest tier member, spent thousands of dollars. And now she has this very rude comment that this is the third time the delivery failed. I work from home. I was here all day. Your driver's lying. So she's being accusatory. She has very high sentiment with frustration and anger. And you would, I don't honestly know. I don't work in this industry, so I don't know what you would do in these situations. If this is something that you would want to immediately escalate to a manager or what. Let's look at the code. Let's look at the code that I have in here for the customer. The short circuit here. You know what? First, diagram for the customer. Oh gosh. There we go. So same basic workflow, but what we're doing in here in the business logic layer in that service before it gets to the agent is we are doing things like sentiment analysis on that comment. So by the time it makes it to the agent, to the triage agent, Can't really read this in dark mode.
Oh, come on.
By the time it gets to the triage agent, we have the ability to, use that sentiment value to make decisions for us. Deterministic things, deterministic choices. So down here, apply short circuit. We're going to say if that person's a VIP and it's been attempted more than 3 times, we're going to say escalate this up to a manager. And then another one here for sentiment. If there's not any like neutral sentiment, just leave it unattended.
Mm-hmm.
So this code, the customer code, looks at sentiment as one of those deterministic data points for figuring out, do we need a short circuit or do we need to let the LLM decide? We have our new prompt, and we actually have a different system prompt too. System prompt is telling the agents, what it needs to do and what its priorities are. And the priorities are different when you're dealing with customers that could potentially be angry and could potentially be malicious, right? We don't trust any of these people. With that, Andres, we need to tailor our guardrails, because if we use the same guardrails right now, let's see what happens. Oh, that's why it's not running our tools. I just had to text.
Oh,
silly me.
Look at
So this is probably going to go through and do things it's not supposed to do because we didn't tailor our guardrails.
It might. Yeah, I don't know. We'll see what chat does.
Yeah. It's not streaming the response, which means it's going through and doing multiple iterations on tools. It's running the agent loop a bunch of different times. So it's trying to figure out what to do.
If you go to the bottom, you have the deterministic check, I believe. Oh, no.
It's just trying to figure out what to do. So it's running that agent loop multiple times. Yeah. We haven't done a session on the agent loop, but what that really means is figure out what I need to do it, figure out if I need to do it again, or do something new.
Or something else.
Rinse and repeat. That's as trivial as I can make that. It's grossly oversimplified.
It's probably a little bit more.
I actually go over the agent loop a lot in my reInvent session. If you guys signed up for that, I'm going to be talking about the agent loop and A2A and MCP at reInvent on Monday.
Noise.
Well, goodness, this has taken a long time. While it's doing this, Andres, we should change our guardrails. This is dealing with a customer. Different, very different things that we have to do, like the relevance. If somebody's trying to do prompt injection, we need to up that contextual grounding to the base meaning of the prompt, right? Is it doing what the prompt said? We need to add a topic policy as well.
Yeah.
Because I don't want somebody to run away and ask, what's the weather in France? All over. So for our topic policy, we can add one. And we can say, let's just block weather. And then we'll
add a prompt.
We'll change the prompt. Any question about weather or tangential weather aspects?
How broad can you be in these topics? Can you tell it everything but block everything but this?
I think you can do, yeah. Because really the way that these are defined with the definition and examples, it sounds like it's just passing it to an LLM to evaluate. So, you can do it that way. What's the weather where I live? Is it going to rain? And what is the highest temperature ever recorded? So we'll block weather for the sake of our conversation here. We have our profanity filter. We have PII. So this is a whole different situation when we're talking about people that are submitting freeform comments to our system. We approach this completely separately and talk about a lot of things. Like we don't want access keys. We don't want people asking about that. We don't want people. is really almost the inverse of what we had.
Yeah, the whole
It's
thing.
crazy. Yeah.
Because they can type in whatever, right? So we got to protect it.
Yeah. We don't want
Swift
IP
code.
addresses. We don't want any of this. We don't want. We're just going to leave it at this.
Yeah.
Content policy. So they have inside of Bedrock actual prompt injection attacks checks. And we want to,
The strength. Okay.
change that. Misconduct. All these things, right? We
Yeah.
don't want any of these things. Is that another one? What else? Hate. We don't want any of these. We're not going to tolerate any of that in our comment system. We're not going to have the agent act on any of these things. We're just going to short circuit immediately. We have a whole bunch of information. And look, this finally resolved. Did a lot of
All
stuff.
the iteration. Yeah.
Trying to figure out what it was doing.
Escalate.
Escalating. Escalating again. I think I broke something. We'll fix this next time.
Yeah.
Anyway, so we have our new guardrails in place, and hopefully this will immediately block it because we have our sensitive information here and our, what was it, topic? I don't see it. There's another policy in here that says don't do hate, don't do insults, and she's pretty aggressive. So let's see what happens. I timed out.
Your token. Yeah. Always
I timed
always
out.
towards the end.
It is. It is. So my credentials expired. The local stuff expired for this. But you know what? This is a pretty good time for us to kind of wrap anyway.
Yeah.
So we're only 3 minutes away from the end. So there's
Aw.
a lot to be said about what we covered. As fun as this is, I had like 8 more that we could have gone through that were all fun and funny. But at that point, we're just testing the different variations of guardrails when really the purpose of today was to talk about agent design and talk about validating and not calling an LLM if you have the ability not to. That's really important for numerous reasons.
Oh yeah.
So Andres, you actually hadn't seen that demo prior to today.
Yeah, there was a
Give me
lot
your
of
thoughts.
work
You always have
going on this from you yesterday for sure. Knowing the why and how it all operates, right? And obviously you would get into a cost comparison between the guardrails invocation versus a full LLM invocation. And it'll definitely make sense on why you want to do these things. But being able to easily visualize how it's protecting at each level, right? We talked about the different layers we have. So it's the input, business rule, and then towards the end, we do the guardrail validation. It's really going to save you money if 80% of your transactions shouldn't even go through to the LLM. And that really could even not make it to the guardrails situation. Is just running through code. So that's pretty neat. And just like you, I hadn't used guardrails until we started preparing for this. And it seems very neatly integrated and very easy to use, right? And all the changes Alan was doing on the UI, those go directly through the AWS API to update those guardrails on your system, right? So it's easy to front that in an API gateway for your management and your system. So pretty neat. And it really covers our fourth principle. I can't believe we're already on the fourth one. We've been going at this, for 2 months, I guess, going through the principles. So there's a lot to cover. If you haven't seen all our previous streams, please do. There's a lot of content around the system prompts, the just do enough context, and what was the last one? Tools. Yeah, tools usage. So good stuff.
And we have 2 more. There's 2 more things. And I'll bring those up to remind myself what they are. But
Yep.
everything that we're talking about, this entire 6-part series, is additive. These aren't pick your favorite thing and design your AI agents with this in mind. It's do all of these. Everything here is critically important when you're talking about building reliable, deterministic, cost-effective agents for any level of production, not just enterprise, but any production software. So next time when we meet, Andres, I think it's 2 more weeks, we're going to be talking about using meta agents. So those are going to be a little bit harder, like a deeper output validation. That's what meta agents are. So they can evaluate errors. They can also evaluate any content that's generated from an LLM. So we'll
yes, the
talk
things
about that.
Going a level deeper in the validation of the outputs, you can use meta agents for, and we'll obviously talk further about that on our next stream, but just to leave that hook, right? It's fact checking and other types of validations, smarter validations, non-static validations that you can do on the output.
That's right. And then our last one that we will do right before reInvent is instrument everything. It's observability, the one that we probably should have led with, but we're going to save it till the end when we have our full agent. So really the big thing here is because everything's additive, we will have our example agents that are full on production ready agents using all of the design principles that we've talked about. And then we'll show you how that looks when it comes to actual OTel and what the metrics are and what the things are to key off of for your agent usage. Okay, so that's it for today. Lots of validation. We actually got to look at code today. I'm going to push that up. That's not currently available in GitHub, but it will be in case anybody wants to take a look at the diagrams or the example agent code that will be available. Promptatron is always available, always free on GitHub as well. We did just move the URL to it, so we can follow up with that. But thank you, everybody. This was a fun one. I'm glad that we finally got to look at some code. I know we have a technical audience, and you and I are both technical. We like looking at code as well. So
for sure.
Thank you. And
thank you, everybody.
We will see you guys next time.
Can I get fireworks?